right, guys. Cool. All right. Well, welcome to Erlang Term Storage. I'm Doug Wright. I work at Versus Systems. We put prizes into games. And so today I'm going to talk about a very cool caching system in Erlang, and specifically Elixir. Has anybody used ETS? I know Desmond. Yes. Okay. Okay. All right. Great. So there are some that haven't. So Erlang Term Storage is just a robust in-memory store for Elixir and Erlang objects. It's basically cache. If you've ever used Rubyists like to use Redis cache. It's a key value store. So this is how you create an ETS table. ETS new, the name of the table, in this case we're calling it a table, would be Atom table, and we specify some options. You have set by default, which gives you an ordered or an unordered set of keys and values, and I use name table here so that I can reference table later when we need to access this cache table. This is how you insert data. : ETS. By the way, : ETS, there are a few atoms like this in Elixir that you'll see, and these are Erlang modules that you get. And ETS stands for, of course, Erlang Term Storage. So we're going to say, call the function insert on it, pass it the name of the table that we just created earlier, and a value. Now the thing with ETS is that it takes tuples by default. It can only accept tuples as data storage. But tuple, as you know, in Elixir can be more than just two items. It can be key, it can be 3-part tuple, 4-part whatever. The values can be strings, lists. It doesn't have to just be a simple string value as it is in Redis cache and other cache services. All right, and then next, if we wanted to look up that key that we just gave it, we call ETS lookup, passing the table name and then the key. I also, in doing this talk, I came across match object, which we don't actually use. Oh, I'm not there yet. So this is an example of what you get back, right? It's just a list. Now I should say here that you don't actually get the tuple back. You get a list of tuples. That's because you can create a ETS storage that has what's called a duplicate bag setting, which allows you to have multiple keys with the same name, and they can have different values. So you could get a list of, if this were a duplicate bag ETS table, and I had several keys in there, they would all come back on this list with different values, perhaps. What's also interesting is you can use match object. This syntax is a little bit funky, but these are a way to basically say, I know that this list, now in this case I've renamed it, right? This is now a list table. But I know that this ETS table has tuples with 2 parts, so give me everything back. And in this case, you'll get a list of everything, no matter what the key and the value. But if for some reason you had stored tuples that were more than 2 values, they wouldn't show up in this list, right? So if this grocery list had drinks, beer, milk, this is a 3-part tuple. Because you specified just the first variable and the second variable, and you didn't say, give me back a tuple with 3 parts, and you don't get it. So that's something, that's just a little, there's a couple of functions like that that are interesting with the ETS, but for my main use case, and probably yours, new, insert, lookup, and lastly, delete are usually the most useful. Also, keep in mind that if you, for some reason, leave off the key here, you'll delete the whole table. And what's also funny about this is that whether a key is in your table or not, it returns true. I'm not sure why. So it'll just always return true. It'll always be happy. So a little bit of a weirdness there with the ETS delete. A couple of other useful helper functions that I found interesting are ETS all, right? It'll give you a list of all the tables in your Elixir app. It'll also show you like what other ETS storage services are used by Elixir out of the box. There's some interesting ones that the application itself is using. And then when you have your names, you can use ets.i to get a little bit more information about your specific tables. And it'll look a little uglier than this, but for presentation purposes, I put it a little pretty, but you can get out data about your table that way. So that's the gist. Now we're going to look at ETS inside of an actual application. So this is actually from our code base. It's a lot, but it should look very familiar, right? We've namespaced our modules, so it's versus systems, user sessions, cache. It's a good use case if you have a lot of user sessions and you want to have a high, you don't want to have any latency with reads, and you want a lot of users to be able to log in and authenticate throughout your application. We create a read concurrency true ETS table, right, that we're calling there the top session store. So it stores all of our sessions for us. We have these little nice wrapper functions that I just went over. Lookup, insert, delete, and then Gen server is just kind of wrapped around all this so that we can spin it up. So I thought it would be useful, and then I just put how you might use this. We separated out so that we have that simple cache wrapper that you just saw as one part, and then another part, which I'm going to dive into in a minute, is our session manager. Hello. Oh, thanks, Java. That's cool. Just got a little note, the Java is updated. Sorry, so this is just how you might get your children supervised. You want to make sure that your cache is up and running before you start calling methods on your ETS table, right? So this is an example, and this is that session manager that I just showed you. So this is actual code from our app. It's a little, so I'll go through each part a little bit just to show you, but basically we are just using the cache to look up an authenticated token that we have, a user session token, seeing if it's in the database and doing some stuff with it. So let's dive in, right? So first off, we call cache lookup, pass it a token, and we're going to get back either a list with that token in it or an empty list. So if it's empty, we know that the user's not authenticated and that they need to re-log in, right, email and password. But if it is there, then we're going to match on token there with a caret, and the value is going to be that session. So now we know we have a session object, and this is essentially a session that we got from the database. When our app spins up, I didn't show this code, but when the app spins up, the cache, this session manager goes and gets all the user sessions from the DB. So in like a previous Rails app, you might have used Redis to do a similar thing where you get all the user sessions out of the DB that haven't expired, and you load that up into some cache, and those are your active user sessions. So the nice thing about Elixir, of course, is if the state machine fails or the process fails, you'll spin it up again, it'll load all the sessions from the DB. And so this authenticate goes in the session store to look for things not in the database. And I sort of put out the method here, active, just showing that I'm just using timex to see if the expired date, oh, we got another person. To see if the expired date has expired yet, basically. And then we do some stuff. So, if the session is active, meaning the expiration date is in the future still, then we're going to authenticate that user and let them proceed with the application. But we're going to update their session so that next time, so that their session doesn't expire. Because what we do at Versus is basically for users, you can stay logged in for a week. So if it's day 3 and you're authenticating through some new route, we're going to extend your date again for another 7 days. So we're going to add 4 days to your expired date. So that's all this does. I didn't really need to show that code. Expiration reset 1 week. We're just extending your due date or your expired date. And then we call that cache table again. And again, you'll see that we're inserting session ID as our key. Updated session is our new session, which just has an expired date that's been extended. And that's our tuple being passed into insert. And that's going to go right into our ETS table. And because we have set our ETS table to a set function, or the option of set, that's a set list, it means that any time we insert a key that's already there, it's just going to update the value. If you didn't want that, there's another way you can do, I believe it's, what is it, Desmond? Unordered set? There's a way that you can do it so that you can throw an error if you're trying to update a key that already exists in the table. So there's a lot of nice little functions like that that you get with ETS. Then I mentioned that these have to be stored in the database, right? So if this process fails, we're going to have to pull these sessions out of the database again, but we want to make sure that that database session has the same data that matches up to our gen server state session, right? Or our ETS cache session. So we just call the cast method to send this updated session to the DB, and we're going to do that in a batch later. And that's a process I left out of this for this talk, but essentially we just are updating the state of all our sessions somewhere else, and on a regular cadence, about every hour, we go through and just put all those into the DB in one big batch. So if the user session had been expired, then we're not going to allow them to proceed. We're going to delete the session from the cache store, and this is kind of what I was talking about before. We have a different module that handles expiring user session in the DB later on. So, again, that's kind of what I just went over, but it's a pretty simple use case, and this would allow you to have several concurrent reads to the system as users are using the application. If you're authenticating every route, which we do a lot of verses, you can utilize the ETS store fairly easily to save a lot of database hits and make your app a lot faster. Funny enough, though, we did this for, these are not players, these are admins for versus systems, and we don't really need this type of speed for about a dozen admins. But it was a fun exercise, and it allowed us to use it when we got into player sessions, which we have a lot of. So, that's me. If you want to look for me online, Mr. Doug Wright on Twitter and GitHub and things. Any questions about Erlang Term Storage? Yeah.
If you're storing things in this cache to prevent database hits, but then every time you have a cache hit, you go and update the database, you save yourself anything.
Well, every time we have a cache hit, we don't update the database right away, because we're doing it later. I didn't show that function, but we're calling it cast.
But it still hits the database eventually. There's still work to do.
This actually doesn't hit the database, this update DB method.
Oh.
It's a map set. It's a map set put on a another cache store of sessions.
Okay. I thought update DB updated database.
Yeah. No, but you're right. Good call. Good question. Yeah. No, we did this in a batch. So basically, we're saving the state of all these sessions in a gen server, or not in a gen server, but in another table, and we have this renew sessions method that we call recursively every hour. And that goes and looks at the state of the sessions in that gen server state, and then if they've been updated, well, every hour it's just going to update all of them that are in there and change their expiration date. I can actually show that code if you're interested. Maybe.
So
yes.
If you delete or rather, if the ETS stuff goes down, then you lose whatever sessions happened in the last hour or whatever.
Yes.
But I guess so then, but that just makes the user log back in, which is fine.
Well, no, actually, our logout, our expiration date, we set at 7 days for admin users. You could set it for whatever. So as long as that database record didn't get destroyed in the DB, when that process spins up again, it's going to pull their user session from the database.
Right.
And yes, it might be a little off.
Right.
Within an hour.
Right.
But
I guess as long as they logged in within the last 7 days.
Yeah, if it was like the end of their 7th day,
right,
and they had hit a new route to authenticate, and they would have been valid, but then if it had gone down, it would have maybe pulled out their, they would have been off maybe.
Right, right. Okay, fair enough.
Yeah.
That seems fine.
Yeah, it seems fine. Cool. Well, just for funsies, since we have time, I don't know, try to maybe show this. This is all like proprietary, not for eyes to see. But here's our user session. session manager. And so Desmond was curious about the update session. So here, when we initialize the session manager, we call renew sessions. You remember this because you helped write some of it. And there's that method I showed for the talk. But in addition to that, when this renew sessions gets called, this is a cool Elixir trick, right? You handle that call. This is what, it pulls all the sessions out of the state, and then it does this DB update for the records, and then it calls itself again. And when it calls itself, it does it in an hour from now. So you can nicely just recursively handle that, and you don't have to have a...
That's a minute.
Oh, okay. Sorry. Yes, a minute. No. Oh, you're right. It's a minute from now, but the offset is later. Yeah, sorry. Yeah. So every minute, I guess, we're renewing. Not every hour. Cool? Cool. Right. Thank you.